So yo quería dar esa charla en español y practiqué con mi novia y es como, ¿qué es esa historia? ¿Qué quieres decir? Y por eso creo que voy a dar esa charla en inglés. Porque la primera parte yo quiero que es un poco charro. Y si hablo español muy mal, no va a ser charro. So, por eso. Okay, so la charla es de... inglés, no, ahora. The talk is about profiling memory and to look basically like if you have a problem with your memory, if you have a lot of memory in your process and you want to find out why, or if someone is playing with your ears and you don't know why, or if you just have a leak, like some people actually have memory leaks that are so bad that they have to restart the applications. If you want to find out why, you have to kind of know how to do this. And it's a little bit complicated. So that's why I decided to give a talk about this. We're going to start with kind of a Toy Story. I actually partnered with Pixar. They gave me these awesome animations, like high resolution animations that you will see. And so I explained a little bit of the concepts with a Toy Story, and then we'll actually get to the nitty-gritty stuff, and I need you to be awake, and I hope you still have some air to be awake because it's going to be a little bit technical. And in that case, I will show you how to kind of find out that you have a leak and how you can kind of track down where the leak comes from and then how you would fix it in your code. And then the last part, I'm actually going to show you a cutting-edge feature that the News V8 introduced, which allows you to sample memory, which is even more useful to track down where your leak comes from. So let's start with the Toy Story and about Bobby. Well, this is me, by the way. I'm very happy here because I'm playing with this TTY thing there. That's what the earliest hackers used in the 60s to program the first program. So very happy here in this case. So let's start with the Toy Story. So we have little Bobby. And little Bobby, he grows up in a house, right? And that house he gets once in his life, right? Not every year, not every birthday. Once in his life, he gets one house. But obviously, it's very cold. He lives in, let's say, Idaho. So he gets some chimney also to have some smoke come out, to have some fire. And also, that chimney he only gets one time, right? One time only. So through his entire life, he only has one house and one chimney. However, he's a kid, so he wants to play with toys, right? So here, he gets a goldfish. But in this time, this is in 2050, everything is kind of Netflix. So you don't buy toys anymore. You go to the Netflix toy store and you rent toys, right? So you can rent up to 3 toys, right? Because they did studies that kids can only play with 3 toys at a time. Once you give them more toys, they get very confused. And of course, I'm making all this up. But so it makes sense to only, so once you want more toys, you have to send back the other toy. I guess you guys didn't go through this phase, but in America, they actually had Netflix that way too with DVDs. If you want a new movie, you have to send back the other movie before you get the new one. So it's kind of like that. So he has his like 3 toys, but then he sees that zebra, and he really wants that zebra, right? And then the toy collector, right? Just remember these terms because it's going to make sense later on how that relates to memory. The toy collector, he says, okay, I'm going to have to collect something from you. And he sees that actually Bobby doesn't really have a strong reference to the penguin. So he says, I'm going to collect the penguin. And Bobby tells the penguin to hide behind the caveman. But the toy collector is smarter than that, and he takes the penguin away, and then Bobby can play with the zebra. So everything good for a while, for about a week, you know how kids are, and then he sees this Triceratops, and I actually put that in my speaker notes because I can't remember. So it's a 3-horned dinosaur, a Triceratops, and he sees that thing, and he really wants that. And the toy collector says again, okay, in this case, you know what, it looks like the goldfish has to go. But Bobby really holds on to this goldfish. Like the toy collector tries to get it, but Bobby, like high-tech animations here from Pixar, Bobby tries to hold on to the goldfish, And the toy collector decides, okay, Bobby has a very strong reference to the goldfish. I cannot collect the goldfish because it looks like Bobby still needs the goldfish. And he shoves in the dinosaur. But now you can kind of see that the house starts getting a little bit full, right? So eventually we'll have a problem. And you're wondering, what the hell does this have to do with the talk? And we'll get to that. So if you look at a server, right? So this is a server setting up here. So we have, we're going to take it apart now. So we have, the first part is kind of like the house and the chimney. Like, we are going to require some modules, and since we will always use the same header, we just already create the header. That is done once, right? As long as the server lives, as long as the server is running, we will have these resources. We will not create them again, right? So that's kind of like the house and the chimney of Bobby. So, right? Now, those are the toys. Like, every time a request comes in, we are also allocating something, right? And that's kind of like a toy because it happens more than once while the server is running, right? So the context, the source, and the index HTML, we create for every request, right? And they should not stay in memory once we're done with serving the request. And why? Well, because if we keep them in memory, then every time we serve a request, we have more and more and more stuff in memory, right? So we need to make sure that all this appears at some point. So, I have some water here. You can read this while I'm having some water. So, memory leak. What constitutes a memory leak? Well, actually, if you're looking at a language like C, a memory leak is something totally different. It is something that where you allocate memory and you don't take care of it later on. Well, we are living in a language, in JavaScript, where we actually have someone to take care of it for us. And it's called a managed runtime or whatever. And it's basically, there's a garbage collector that makes sure that it cleans up your memory. So you don't have to actually worry about that. However, the garbage collector looks at all the objects and tries to figure out if you still need them, right? And then the ones that you don't need anymore, it collects. However, if you somehow still hold a reference to some object that you actually don't need anymore, then the garbage collector won't collect that. And if you do that too often, you have a memory leak. That's kind of like Bobby with the goldfish, right? If Bobby keeps holding on to the goldfish, the toy collector goes up, and then you have yourself a leak. And that is especially bad if those objects, they're kind of, they're created a lot, right? So for instance, for every request. And if they're big, and then you're going to have this problem, right? You have a leak. And you're probably saying that, you know what, yeah, that's a nice story of this little kid, Bobby. I'm not Bobby. I release whatever I no longer need. I believe everyone in this room, or at least let's just speak for myself, I have created memory leaks. Everyone at some point will make a mistake. We are not perfect. We will create a memory leak. The number one cause for memory leaks are registered event handlers, and that's especially true in the front end. Right? Probably some of you have worked with Backbone, and there were all these cases where you created a Backbone view, you registered some events, and then you were done with the view, but somehow the view was hanging around because there was still some event handler that you didn't clean up. Right? In Node, we also have an event emitter, so that could happen as well. And the event handlers, basically what they kind of, they're kind of a higher level abstraction and have a function closure inside of them eventually, right? And with Node, we're actually dealing with function closures directly more often because we have a lot of callbacks, unless you use promises, and then you still have callbacks and other problems as well. So function closures are in Node a very big reason for memory leaks. And number 3, registered event handlers. I already said this, but it's so often that I put it here twice. And then we have leaking connections. And leaking connections happens sometimes when people have basically the code that works perfectly whenever everything is fine, but when an error occurs, they may have an error handler installed that kind of makes sure that the server doesn't crash, but then the connection that they created doesn't get cleaned up, and then they're leaking connections. And if then somehow they're holding on to something else with that connection, then that leaks as well. So in order to understand this a little better, we have to understand the garbage collector. And this is where I said, kind of wave your arms a little bit, try to be awake. It's a little dry, but we have to understand this a little bit. So the garbage collector, what it does, it follows the retaining path from a root and tries to get to an object. So it's like, oh, here's an object. Let me try to get to it. And if it can't get to it anymore, right, then it decides, okay, no one seems to be needing this object anymore, so I can collect it. So, and you're wondering, what's this root and this retaining path that you're talking about? Well, that's not it, but it's pretty. This is what I'm talking about. So number one here is the root. And then there are a bunch of objects. And the objects that are at the very end could be primitives, for instance. Could be a number because you don't have another object that they're holding on to, right? So node 1 is the root node, and it dominates all the other nodes. That means in order to get to any of the other nodes, I have to go through the root. Otherwise, I can't get there, right? Then node 8 and 7 have no reference to any other nodes, and therefore their retaining size is the same as their shallow size, right? So the shallow size is like, if it's a string and it has like, let's say 3 bytes or whatever, then the shallow size will be 3 bytes, and since you're not holding on to anything, their retaining size is the same. Node 6, however, retains node 8. So I go through node 6 to get to node 8. So therefore, its retaining size includes the size of node 8, right? So it's the size of node 6 plus the size of node 8. And that's what we mean when we talk about shallow size and retaining size, and we have to understand this a little bit because we're going to look at dev tools in a second, and there's this retainer view, and so now you know what that means. One interesting thing here is the nodes 9 and 10, they're kind of in space, right? So the garbage collector knows to collect them because there's no way to get from the root to either 9 or 10. However, what happens if node 9 references node 10 and node 10 also references node 9? Well, they're still out in space, so with the garbage collector we are using in V8, it will be collected. However, there's another algorithm that the older Internet Explorer used that's called reference counting. And so if you have 2 nodes referencing each other, their reference count is 1 because they're referencing each other. And that's how you got memory leaks actually in Internet Explorer, because that algorithm has that flaw. And most languages that have a garbage collector now use actually the one that V8 uses and that we use in Node and Chrome as well. So, but even with this awesome garbage collector, if we reference nodes we no longer need or objects, then we get ourselves a memory leak because the garbage collector doesn't know that we don't need it anymore because it looks like we still need it. So how do you troubleshoot leaks? Number one, and that's like the hardest part sometimes. Like, so you might see a leak in production, right? It's growing, but you don't know what's causing it. You try to reproduce it locally, and you can't. Then it's much harder than what I will show you, right? So if you can reproduce it locally on your own machine, you're already like halfway there, because that's actually the hardest part sometimes. So, and sometimes if the leak is very, very large, you can just watch it with like a process monitor on your machine, and you can see the process going up in memory. And we'll see that eventually it will actually crash sometimes. So we'll look at that right now. So I wrote an app here that has a memory leak on purpose. So if I start this up, and then I go over here, and we're going to just launch htop. Oh, that's good. Let's try this one more time. Wow, okay. Thank you, htop. Okay, let's try top. All right. So top is not quite as cool, but at least it works right now. Here we can see all our, and I have not used top in a while, but we'll go with this. So actually, let me get out of here and go back to where it was, and let's just launch top here. All right. So here we can watch our processes. Now, if I go back to over here, I can kind of load our process. So basically, I'm just going to show you what this does. So I have a script here that's called curl, and I used to have a script that's called AB, but we'll just make it up. Has anyone used Apache Benchmark before? it's pretty neat for these kind of cases when you just want to quickly reproduce a problem. So we're going to load our server. So we're going to say concurrency 10, and we're going to do like let's say 100 requests, right? And then we're going to go to our localhost 5,000. Okay. So now if we go, we're going to run this, and we're going to go to top, and we should see our, I have no idea how to search in top. Somewhere we should see our process. Well, we may not get the top view then. But basically what will happen is eventually it will go up and up and up, and you will see it with more and more memory. And then eventually it will crash, and we're actually going to do that now. We're going to do 1,000 requests. Okay, still working. Okay, now it crashed. Over here, what happened is it ran so much memory, it ran out the heap that V8 gives us. So by default, V8 gives our JavaScript 1.5 gigabyte for a heap. And once we run out of that, so basically what's happening here is V8 said, okay, I try to allocate a new object, and it was trying to clean up the other objects, right? And it couldn't, because they all were supposedly needed, right? You held on to all these objects. That's kind of like with the goldfish where it was overflowing. And so once it couldn't put a goldfish anymore, it just did this. It says, okay, I'm done. Like, I can't allocate this object anymore. There's a serious bug in the application. All I can do here is crash. Wait. All right. So that is like the easiest way to prove to yourself they have memory leak. If your application crashes because of with this, you know you had a memory leak. However, if your application keeps going up in memory and up and up and up, that does not yet mean that you have a memory leak, because a garbage collector is not super aggressive, because the garbage collector takes time, right? So in order to improve your performance, it will say, okay, I'm going to hold back. I'm not going to do anything yet, to make your app perform better, because it will run on the same thread as your app is running on. So while you're garbage collecting, your server basically stops, or in the browser, your application basically stops. So therefore, it's not as aggressive. So you basically have to show that it keeps going, and then you have to call the garbage collector maybe forcefully, which we'll show in a second, to make sure that you're actually leaking, right? So what you do, you reproduce, and then now we want to isolate and find the culprit. And there are various approaches. We're going to show the approach with DevTools. So what you do in order to kind of troubleshoot this, there's a system. You don't just like randomly run it and then kind of look at it once in a while. No, you're very organized about this. So you try to figure out what, for instance, on the server, what route is it that's causing a leak, right? Is it like the login route? Is it like getting some assets route? I don't know which one it is. So you try to figure out which one it is. Once you figure out which one it is, you basically curl that route, or you perform an operation. You could also do this from the browser and like to exercise your server, right? You do this one operation that you think is causing the leak. And then you're taking a snapshot, and that's your bottom snapshot. So if you're thinking about a request, right? So we built the house in the chimney when the server started up, right? And now what we're doing, we're serving one request. And then when the request is done, everything that is needed in general to serve this kind of request is now allocated, right? So now if I have any future requests, everything that they create should now be collected, right? There shouldn't be anything hanging around. So once you have that bottom line, we're saying, okay, after this, we shouldn't really create more memory. So what we do, we perform the same operation, we take another snapshot, and you can do this as often as you want, and then you load this new DevTools. Another demo. So we're going to start our app again. And what we're going to do, again, I'm going to show you the script that I wrote. So what we're actually doing here, we're running curl, exercising the route once. So that's what we think is causing the leak, just the root route. And then we're calling the garbage collector twice. And you're wondering, how are you calling the garbage collector? Well, there is actually a way to do this. So basically what you can do, you can run your application with a flag that says expose GC. And then magically this global variable GC, which is a function, appears in your JavaScript. And that now you can call GC, and that forces the garbage collector to garbage collect. And we're using that to ensure that we actually really got a leak, because as I said, the garbage collector may not collect yet. So this way we can force it. However, don't use this ever in production or anything. Don't try to tweak the garbage collector like this. It's just for diagnostics purposes, right? So this is basically how it works. If you go to the garbage collector route up here, right? Then it just calls basically our function and it collects garbage, and then we know garbage collector ran, and if our memory keeps increasing, oh, and now we can take a heap snapshot, and then we know everything that's still there wasn't collectible because we tried to collect, but it's still there, right? So I'm running on that. Just to show you also, over here you can see that we are running it actually with this flag, right? ---- expose GC. We did that so we can then call the garbage collector. So now I'm going to run this curl command one time. Okay, now we get to the next part. How do I take a memory snapshot? Well, there are different ways, there are different modules you can use. In this case, I'm using the heap dump module. And basically all you do is, in your code, you require the heap dump module. That's all you have to do. And then the heap dump module does the rest of the magic. Now I can go over here. And basically what you do is you send a user2 command. So as you kill your process, it looks like you're killing your process, but actually you're just sending a command. You're sending a user2 sick command, and then, but you just basically have to, you don't have to understand all this, you just have to remember that you have to type that. And then I'm going to give the process ID, right? That's printed up here, right? The PID up here. Very important for you to always print process.id when you start up your server. Otherwise you can't use these tools. I have 8 minutes? Wow. Okay. Okay, I'm going to race now. Okay, so we're going to send this. We have a snapshot, right? Now I'm going to run the curl again. And you can see up there, collected garbage, do it again, run curl again, and now we're going to do this real quick. And okay, and now I have a bunch of heap snapshots, right? Now I'm going to open DevTools. I'm going to go to profiles. I load it in. I have these. I have to load them one by one. All right. Okay. So now we can already see that each snapshot has a little more memory, right? See that? We're going from 7.7 to 8.2 and so on. And in the essence of time, I'm going to explain this really quickly. So basically, you could look at this in a summary, and you could find it this way. But there's a better way. You can say, I want to compare heap snapshots. So we're saying, if we allocated something during the first request, it should not be there anymore in the fourth request, right? Because we said after every request, we should have collected stuff. So you can say, I can go to the last one, and I can say, show me all the objects that were created between the second request and the third request, or something like that, right? And now whatever is still there now is the leak. And now we can basically look in here, and you're going to find out that it's actually some watcher that's going on. Okay? And I can basically also see what is leaking here. It's leaking strings. Okay? Now, and you can see here there's a function on file changed. Now you go to your code, you find that function, that's where leak is. And I'm sorry I had to explain this really quickly. But there's a similar talk that I have where I go into more detail and slower, and I can post it on Twitter later. Okay. So I hope that's all clear. So basically, like, we found the leak by looking at where the string was held on. Let me just explain this a little bit, though. So we have the string, and the string is named content. And the content is held on by context. As I said, it's kind of this, remember the retaining path? So you have to read this kind of backwards. So the content is at the end, which is held on by context, which is held on by change, which is held on by ends, and so on. And then basically we end up in this, well, the context here is held on by our function. So that's the function closure. Remember I said function closures are big causes for memory leaks, right? So now let's go back to the talk. So one important thing, I don't know if this is true anymore, but in the older Chrome there was a bug. If you didn't turn on this function, like the view that I just showed you doesn't work. Now is another demo time, but I kind of already showed you everything I wanted to show. So we'll skip that. So now we kind of have to fix the leak, right? If you're interested, my slides are online, so you can see the sample code of the leak. So now we're going to go through some considerations. If you wouldn't have named your functions, it would look like this. You wouldn't know what to look for in your code. Because a function is an object, if you don't name that object, the heap doesn't know what it's called. It will just give an ID. You have no idea where in your code that function was. Right? It's very, very bad. So now we're going to look at what it actually means to name the function. Is this okay? No, it's not okay. Because this part is your function. Only that part. It doesn't matter what you assign it to. The object is on the right side. So Chrome doesn't magically name it for you. It doesn't work. It doesn't happen like that. Is that okay? No, not okay. Same story. The right part is the function name. You have to name that, the declaration. Is that okay? All right. So that's how we do it. If you want to inline functions, you can still name them like this. The important part is in between the function thing and the parentheses there. That's where you've got to put the name. Now, is that okay? Yeah, year 6, cool, right? We're all using error functions. No. Error functions, and you can't name them. So there's no solution. I can't show you how to do it right. There's no right solution. You can't name error functions. Sorry. So don't do that if you want to find your functions. I only mainly use error functions for function expressions, so you can do that. I'm racing. So now I'm going to show you the last cool thing. I got 5 minutes? All right. So we got 5 minutes for actually the cool thing that's coming up. So this is kind of a bleeding edge feature of the latest V8, which is now part of Node 6. And basically what it does, when you allocate, right, when you say create a new object, or when you say I'm creating a string, it allocates space for that in what's called the new space. And basically you can say sample, every time I kind of like create something there, sample that, and then tell me which function had the code that ended up creating this object. So you can sample these memory allocations. So with a heap dump, you're going to look at, okay, it's kind of like looking into this bucket, and you can see what's in there, but you don't know when it was created. And you can kind of see who's holding onto it, but you don't know who created it, right? You don't know which function the code was in that actually created that object. With these sampling, memory sampling, you can actually do that. So I wrote a module, an add-on for that basically calls this V8 API and uses the V8 API and then converts stuff to make it more consumable. So you can do this. You can say, hey, start sampling. You say every 32 milliseconds, stack size 10 to see how deep you want to look at. And then you get the allocations. And then you get something like this. And I will actually show a demo now for this. So I wrote like a little web app for that. I can run that. And so here what we're doing, we start sampling. Then we call some, well, I have to actually wait. Sorry, I keep doing this. I have to wait till this huge bundle finishes loading. Okay, and now I have to press enter. This is when you're trying to race. It doesn't work. All right, so let's do it again. To wait till this thing is done over there. Okay, now I'm going to start sampling. Now I'm allocating a flat array. I'm allocating a nested array. So this is basically my server doing that. And then I say stop sampling. And now basically what it will do, it will collect all the data and show it. And just to see how much data we have, I also saved it to this JSON file. We got 12,000 lines of JSON. So it's pretty big. We can actually also look at it. So you can see kind of what it looks like. So you have the nodes here of the functions, and then you can see the stack, and you see what the functions are called, and you see all the allocations that went on. So the count, 8, and the size, 55, and so on. But that's kind of hard to look at, so this is much nicer. So this is a sunburst, and you can kind of look at it and say, okay, which part has the most circumference, right? And that's basically where most of the allocations happen. So here I can hover over this, and I can say, oh, big surprise in the allocate function, right? When it was basically allocating the array. I can look over here, and sometimes they appear twice because depending on how they got there. But you can definitely see we have a problem in the inner outer array function. And then we have another function, collect nodes is actually my add-on working. So you can also see that happening. All the thin ones we are not worried about. That's actually just Node doing stuff, and you can see it's very efficient with the memory. It doesn't allocate much memory, so you can look at it there. If you don't like, this is actually, I like this visualization. It's called a sunburst. If you use, anyone used flame graphs before? Yes. So flame graphs. More people are usually familiar with flame graphs. It's kind of like the sunburst is kind of a flame graph in a circle, and so now this is kind of the circle folded out. It's the same thing. We can look at kind of where and we can see how we got there. So we can see entirely how the memory was allocated. It's very useful to troubleshoot memory leaks. You can also look at it in a tree view. Let me make that a little smaller. So the big circles are basically where most memory was allocated, and so you can see the entire stack trace, which function called which function, and so on. It's pretty useful. And down here you have something called a tree view. Tree map view, and so you can also see that the biggest squares are where most of your memory is allocated. And now you could go to that function, and you can figure out what to fix, right? Pretty cool. The other thing that's coming, supposedly, they told me, that it'll actually tell you where in the function it was, right? Right now you only have the function name. You don't know which line on the function was actually allocating memory. Hopefully, though, you guys are all writing small functions. So you have a small area to look at, right? But in the future, the V8 team will tell you also the line in the function. So, so here we have basically that bad function that was causing all this trouble, and we can see we're allocating a bunch of arrays here. So I already demoed it. Now, resources. If hopefully this got you interested into understanding a little bit more about this. A while ago, I created this repository on GitHub called V8perf, which basically is me collecting a bunch of information that I find about how V8 works under the hood, which is relevant for you for the browser and as well for Node. And so for this talk, you would probably want to, if you want to dig deeper, you would want to look at the garbage collector and at the memory profiling section. And finally here, I have a link to the add-on that I created to basically pull out this data about the memory sampling, right? So you can actually look at, some people were in the workshop yesterday of how to write add-ons, so you can kind of see how I wrote an add-on to pull out this data from V8. And that's all. And I put this picture because there's more on the horizon. So there you go. Thank you.